right. Hi, everyone. Welcome to today's webinar where we'll be exploring strategies for improving the ROI of AGVs and AMRs and diving into Flexware Innovation's intralogistics platform Lift. My name is Ellie Allen Bathe, and I'm a content marketing manager here at Flexware. Before we get started with the content for today, just a couple quick housekeeping notes. First, if you have any questions throughout today's presentation, feel free to drop those in the questions tab of the toolbar. And once we finish up the presentation portion, we'll go ahead and answer all of those for you. Secondly, we are recording today's webinar and we'll make that recording available to you shortly after we wrap up. And then finally, we're scheduled for 45 minutes today, but if we wrap up early, we'll give you some time back into your day. Now that that's out of the way, I'd like to introduce the two speakers who I'm here with today. We have Brian Wheat and Will Nichols. Brian Wheat is Lyft's product manager. He has over 25 years of experience working with innovative hardware and software solutions, and he specializes in cutting-edge technologies like robotics and automation. And then we have Will. Will is our senior products engineer, and he has spent more than 8 years at Flexware. He serves as a technical consultant and assists with product management activities, including acting as a liaison with other technical partners. He also leads our new product research and development efforts. Guys, take it away.
Thank you, Ellie. Appreciate that. As Ellie said, my name is Brian Wheat. I'm a product manager here at Flexware Innovation. Super excited for everyone to join us today. I think we've got a nice 45 minutes of information that hopefully you'll walk away with, at a minimum, information you can use. Before we jump right in, let's talk about the agenda really quick. I'm going to take just a few minutes to talk about Flexware and where the company came from and its origin story, but we're going to dive deep on the problem space that we're focused on here today. And then we're going to dive even deeper as we look at the solution and take a look at a demo of our solution here at Flexware Innovation. And then we're going to wrap up with a little bit of a glimpse into 2026 and our roadmap for the product, and wrap up with some Q&A. So let's go ahead and get started. So a little bit about Flexware. So Flexware is a digital transformation services company, and we focus on manufacturing and warehousing. We were established in 1996 in Indianapolis, and in 2022, we were actually purchased by Hitachi, and this has greatly accelerated our growth and investment. We have over 200 employees worldwide, and with that, 30 years, nearly 30 years of experience. We have over 6,000 projects, tons of experience, primarily in the area of automation and controls, systems integration, software development, data innovation, and also we have purpose-built products, one of which we're going to take a look at today called Lift. Our industries are broad-based. We have quite a bit of work done in pharma and life sciences, as well as medical devices. Food and beverage is really a strong focus, as well as consumer and packaged goods and automotive, and also in discrete metals and utilities. So that's a little bit about Flexware. And one of the things that we're going to talk about today is all these 6,000 projects that we've done really allows us to look at best practices and culminate that. Sometimes that culminates into consulting, but other times it culminates into products. And what you're going to see today is all that experience kind of wrapped up into a product. And that product is called Lift. But before we dive deep into that, we're going to first take a look at the problem space. We want to really focus what area that that Lift is focused on. And really what we're talking about is material movement, and more specifically, material movement in manufacturing. So for our purposes here, we're going to be ignoring all the things outside of your facility, and we're really going to be looking at dock to dock within your facility. And while we're focused here on manufacturing, please remember that this could equally apply as well to just warehousing and distribution. as well as manufacturing. So we've got a real basic diagram here, but I want to just point out a few things. You know, when we're talking about within the four walls, we're talking about receiving, production, and shipping. In receiving, you're generally talking about, it's pretty straightforward. You got material movements, mostly point to point, pick and drops, truck unloads into warehouse locations. Usually it's in bin racks and other containers. And sometimes there's kitting where multiple materials are located. And then moving into production, you've got typical routing scenarios there where you're moving product from operation to operation. Sometimes that includes just floor space. Other times you're moving into conveyors that are feeding machines and so forth. Sometimes it's into buffers in the manufacturing process. And so for production, then we moved into shipping. And again, shipping's pretty straightforward. You may be going right from production into a truck, but oftentimes there's a container or some sort of warehousing that's contained there to put the finished goods. So that's what we're talking about today. That is the scope of the problem set. In addition to that, though, we want to take a look at the systems that are in place to help facilitate that. And so we're going to take a look at these systems that are often in place. You may have some of these, you may not have others. They may be homegrown, they may be off-the-shelf products that you've built or that you've bought, or they may be custom built by systems integrators or other companies. There at the top, we've got what's known as enterprise resource planning. Oftentimes, this is the financial business system. Usually, it's got accounting, accounts payable, accounts receivable. But what it also has, which is pertinent to material movement, is order management and high-level planning and scheduling. As we move along the sides there, we'll get into more real-time information, which includes warehouse management. So now you're looking at inventory, as well as manufacturing execution. And here you're looking at information related to bills and materials and routing. So now we're planning for the manufacturing execution and making that happen. So we're getting closer to the shop floor at this point. Moving along on the sides, we've got supervisory control and data acquisition. Oftentimes you're collecting data and you're supervising and doing the scheduling, day-to-day scheduling. And again, we're getting closer to real time here as we move down to the bottom. And this also includes robot fleet management. For those of you that are thinking about it or adding robots to your organization, that requires fleet management, which is a software application usually provided by the vendor to help plan missions that those robots take, the actual travel that those robots will take in your facility. So it's a very key component here, and it's very important, obviously, in the material movement space. Getting closer to the bottom there, you've got your machine-human interfaces. This is where the operators are now facilitating, turning machines on, off, monitoring the machine status, maybe initiating requests for material, all sorts of things that an operator might be involved with, as well as physical movement where necessary. And then you've also got programmable logic controllers. These are the automated machines that are real time. These are the machines that are turning on motors. They're opening valves. They're doing the things that are automated in your processes. Again, related to material movement in so many ways. Finally, at the bottom, we've got your guided vehicles, including manual machines such as hoist jacks and forklifts. AMRs are real common now, mobile robots in addition to guided vehicles. You also see, doors and conveyors in this level that, for our purposes here, are related to material movement. So let's take a look at a real simple use case. Let's say you're adding autonomous guided vehicle to your production process. You want to pick material from a staging location and deliver it to a pick and place robot in production. This seems straightforward, and in some ways it is on the surface, but to make it work, you actually need to communicate, as we stated, at a minimum to the robot fleet management system, which initiates the guided vehicle on their mission and send it along its path. However, most of those systems need a trigger to tell it to start, and oftentimes that trigger comes from either maybe an order management system, which is your ERP system. So now you need to communicate, or at least have that initiation come from either the order management and ERP, or in the manufacturing execution system, could be a trigger, or from a human machine interface, an operator on the shop floor. So now you've got three systems there that really need some communication to initiate this. And there may be a programmable controller on the shop floor that monitors the in-feed on a machine, and it's going to trigger that. So, and then ultimately, you're going to need to direct to the robot and maybe open a door or turn on a conveyor. So suddenly, this simple operation has turned into a pretty complex thing, all initiated ideally automatically, and partakes, and everything is orchestrated together, but the reality is oftentimes it's not. And the reason why is that these systems are often in silos, and when they're in silos, they don't communicate as well, and you need to plan for that. And so what oftentimes happens is what a simple introduction of an autonomous vehicle introduces much more complexity, delays in the startup of the machine, delays in the or increases the startup costs, and oftentimes if you don't plan accordingly, you're going to get downtime, unplanned downtime, misroutings, bottlenecks, delays, and even sometimes injuries. So that is the problem that we are trying to solve here. And the bottom line is, you don't want to have to reinvent the wheel every time you're doing some sort of initiation or initiative that improves your process. And without the integration of these systems, oftentimes it feels like you're reinventing the wheel every time. And so what you need is a way to configure and execute advanced material movement in a way that's without needing a computer science degree and hundreds of hours of effort. And this is why we built Lift. And as I mentioned, 6,000 hours of projects has culminated in us developing this product focused primarily on material movement throughout your facility from dock to dock. Right? It's a purpose-built unified platform that orchestrates material movement throughout the entire production process. So it's designed to connect the people, processes, and machines into a centralized flow engine that's capable of orchestrating and movement across any production environment at any scale. So it acts to integrate these systems together. And we do this with a packaged integration platform. So interfaces to these systems are standardized and focused on material movement. So Lift ends up being the one tool you need to set up, manage, and scale these material movements. And so you're well on the way to unlocking value. And once you start connecting these systems, you start to see unhidden ROI that you never thought was never uncovered. You will see reduced implementation effort, cutting costs and complexity. With productized integrations, you get faster implementation and better connectivity, and you're set up for continuous improvement efforts, adding mobile robots and from multiple vendors, bringing them together and orchestrating their efforts so they don't trip over each other, so to speak. You'll have a unified data layer, and we'll see the power of that in some of our new releases in 2026. It gives you unparalleled access and data utilization. And then you'll be empowered to implement those changes and doing cost-cutting, cost-effective, continuous improvement. And being able to visualize this allows you to simplify your operations so you can optimize. And that's really our core competency here and the core value set that Lyft provides. Okay, so I've talked a lot. I'm going to let you see the product in action. And with that, I'm going to turn it over to Will. And he is going to, well, before I do that, let me talk a little bit about the feature set here. So at the top line, as I mentioned, Lyft is a centralized multi-agent orchestration platform, and it's got flow-based configuration. So you'll see that in Will's demonstration. Easy to use, easy to configure, has logic built in, so you can do what-if scenarios and have real-time reactions to those. It has, as I mentioned, a robust integration framework that allows us to connect to all these different systems. Some of those have been we've already developed, and we have connections to those. Others are in the works, and we're happy to work with customers to get those new integrations in. It has advanced user management, including roles-based, so that operators and managers have different access to different information that's pertinent to their role and keeping them more efficient and productive. It has a great comprehensive alerting system to keep people focused on the things that matter in real time. Global accessibility, so its user interface is universal. It's often so you can deploy it wherever your organization grows, whether it's international or here in the U.S. It also has air-gapped installation, which this provides a more secure and reliable installation on your facility within your four walls. And then, of course, we provide full documentation and support and maintenance. All right, so now we're going to turn it over to Will, and Will is going to show you a detailed demo. Will, take it from here.
All righty, thank you so much, Brian. So as Brian mentioned, we have a demo environment here in our Indianapolis facilities. They're actually right above my head right now, and you can see the two images here. So with our demo environment, we're trying to emulate a common material movement scenario. We're going to receive an order from a system to move material from A to B, and we'll have to go through an intermediate staging area to make that material move. So in our example, the material is going to be represented by colors. So you can see these LED arches represent our locations. And then the robots also have LEDs on top of them that will light up as they have a material on them. So obviously an LED with a color represents a material that's in a container. These white arches that you can see here represent empty containers. And then the LED arches that are off represents unoccupied locations with no container present. So one thing I want to point out here is that Lyft is right now orchestrating between three different systems. So we have our auto fleet at process A that'll be handling process A to staging. We have our mirror fleet at process B that's going to be moving our material from the staging locations to process B. And then finally, we have our order management system. This is just a quick little form app that we have that just can submit material movement orders. In this case, this would be emulating or simulating an ERP, WMS, WES, that sort of thing. So the way that Lyft manages this orchestration is through what we call flows. And a flow is simply just an ordered set of tasks that define a process. So as you can see here at the bottom of the screen, we've got 4 flows defined to handle this material movement. So we have fill process A. So fill process A is going to be triggered when we submit that order from the external order management system. We're going to receive an order ID as part of that trigger, but that order ID is not the full set of information. So we will actually, within this flow, call back into the order management system to retrieve the color. An example here would be if you had to call back into your ERP to retrieve a bill of materials or inventory list or something along those lines. Just some additional information that you have to have in order for your business logic within the flow to execute. Then this fill process A will take all of that information and marshal it into the appropriate location attributes on process A. It will mark process A as occupied. The next flow here is process A to staging, and it's triggered when the process A's location occupancy flips to occupied and the location attribute for the order ID and the color have been populated. So that'll be triggered, and that the first task there is going to have the our auto 100 go over there to process A and pick up the material. Then we're going to, then the auto needs to know where it needs to drop that material off. And so Lyft has got this concept called a location search that can find an available location based on criteria such as location name, location group. We can also do filtering on occupied status or location attribute values. So in this case, we're going to be looking for a staging location that is not occupied. Once we've completed that location search, we'll have the auto move from process A to one of the staging location that it's selected. And then the auto will handshake with the arch to move all the material, move all the information over. And that will then trigger the next flow, which is staging to process B. That staging to process B is triggered when the staging location is occupied and it has the order ID and color attributes set appropriately. That's then gonna have the mirror come and move to that staging location, and it's gonna perform a handshake between the LED arch and the mirror. So an example here, we've been doing handshaking throughout this flow, but I wanted to call it out here specifically. And what we're doing when we do this handshaking is we are moving custody of the order ID from the arch to the mirror resource by retrieving location attributes and populating resource attributes. So we're moving that data from our location to the resource, which is the mirror in this case. And then when the mirror moves to process B, it will do the opposite and handshake that information from the robot back to process B or over to process B. And then finally, we have consume process B, and that's triggered when process B is occupied with the order ID and the color. So this flow will handshake with the machine at B to make sure that we're ready to consume that color, and then it will go ahead and consume that color. And then process B will also call back into the order management system via REST and confirm that that order has been completed. So at this point, let's transition over to a live view, and we will go into our flow here. Oop, looks like our auto vehicles are in the middle of charging at the moment, but that's not a problem. We can see, I need to, yeah. So you can see here in the top left, this is our process A to staging. And then here on the bottom, this is our staging to process B with the mirror fleet over here. So first off, let's go ahead and submit an order. I'm feeling pretty blue today, so we'll hit the blue button and that'll go ahead and submit that order. So if we come over here, we can see that process A to staging flow is executing at the moment, or fill process A completed in 1.5 seconds. And we went ahead and set that arch, that LED arch to blue. So we can actually click in here to the flow. And we can see these flows executing in real time. So right now, this was our trigger, and we're executing that pick mission at the moment. You can see here, these are our handshake blocks, where we'll take that SKU from the machine and transfer it to the robot. So now then we completed our location search, and then we're going to have that auto go drop that off. So I want to point out here, we've got this timeline scrubber at the bottom. And if I open up this show variables tab here, we can look at the flow variables. And as we scrub through here, we can see that this staging location is not is null up until the point we execute that location search, at which point we've discovered that staging location 3 is where we want to drop that material. So right now that auto is executing that drop and looks like it just finished the handshake there to process, to state that staging location. So let's back out of this, and now we'll look at staging to process B flow. So we can see here that this has an inventory here of the link to resource here. So this is the Spidey resource. Then we also have a list of all the locations that are used with this flow. So if we go over here to this, so we just handshaked back to the robot. We are executing a location search here to make sure that process B is unoccupied. We've got a space to drop the material. We'll go over here to our near drop task. It's going to drop that at location B or process B. And then if we come over here, we can see that we've triggered that consume process B flow. And we'll see it here. It's consuming blue. So it'll go from blue into party mode because we've consumed the material, and then it will return with an empty container. So with that, let's get into how this can be accomplished. So we talked a little bit about, whoa, I lost my mouse. We talked a little bit about flows and earlier, and a flow is simply a ordered set of tasks that defines a process. So every flow has a start, it has a series of tasks, then it has an end. One thing I want to point out here is these flows are all version controlled as well. And we also have the option for a approval process that we can execute in environments that require more regulatory scrutiny. These tasks can be anything from all of these core tasks here, which are more of your control flow tasks. We have location tasks, resources tasks, and then if we scroll further down, we see tasks that are associated with each integration. Let's talk a little bit about what tasks are first. So a task has 4 handles. We have a an inbound handle. We have an outbound handle. We have a retry handle, we have a fault handle here. And this is used if you need to do, right now I'm just going straight to a fault here. That's what would happen if this were unoccupied. It would just fault the flow. But this allows you to do things like create a log entry or emit an alert when that flow faults before you go ahead and fault the flow. And then the last thing we have here is a retry handle. So this retry handle will actually, if this mirror pick fails one time, it will go back to this conditional try that again before moving on. And that is our flow engine. So you're probably asking, how do we get these tasks on here for the various vehicle integrations that we have? So Lyft accomplishes this through integrations. And these are packaged interfaces that interface between Lyft and an external systems. These integrations do 3 things. First is they supply a translation layer that simplifies interacting with these external systems. This allows us to do things like map locations to Lyft locations, map vehicles, robots, manual vehicles, people, whatever, to resources. And then coming soon, we'll have the ability to manage inventory if needed. These integrations also provide tasks for the flow editor. So if you can see each one of these tasks here is associated with a specific integration. And then it also provides data points for reference within Lyft. Now, A data point is simply a identifier assigned to a specific piece of data. It allows that piece of data to be referenced and used by all system components in a similar manner. So let's go over to data points real quick. And at the end of the day, these data points are just another word for a tag. We've got a tag browser here. We can see current values. And these data points are important because we can do things like read write to these data points from flows. We can map these data points to attributes on a location or a resource, which we'll get into here in a moment. Circling back to integrations, so let's pick the mirror integration here. So this is where we have all of our configuration here for the mirror integration. We've got mission selection here. So the mirror has a custom task where you can execute predefined mirror missions. We also have location mapping, and this allows us to map locations from the mirror fleet manager into lift locations. Now, a location is just a representation of a logical representation of a physical space. And Lift allows you to tie and connect and link these locations across all of your integrations together so that when you refer to staging one, you know that mirror staging one is this location, and you know that Auto's version of staging one is another location, or is the same staging one location. So if we come over here to our locations browser, we can see here we've got our process locations here. So process A is associated with the auto integration and the LED integration. Process B is associated with the mirror integration and the LED integration, and then the staging locations here are referenced among both. These locations can have names, and then they have some pre-built attributes. So they've got enabled, occupied, blocked, and unassigned, or assigned, which is like a location lock. And then we've got the ability here to create these location attributes. So we can see here that this LED preset, that's what's controlling the color of the arch, is mapped to this staging one LED. So from the flow, when we set the location attribute for staging one to red or blue or green, because that's mapped to a data point, we will actually write that data point back to the LED integration, and that will transition the color. So think data points, maybe potentially interfacing with OPC UA or MQTT or other sorts of things to really be able to enable that bidirectional communication to empower your business logic within your flow. Next, we have resources. So we can see here, these are the resources that we have available to us. We can see here that we have our 2 auto resources and our 2 mirror resources here. So Alan, this was the robot that just executed the flow. So just looking at his last hour here, we have a timeline of his state. We see his resource attributes. And then we can also see a list here of his flows that he's been involved with for the last hour here. We can also go into these flows. You can actually view the flow here. And just like always, we can come back here and scrub and see the execution of that flow. So we got to go back to the resource ID. We can also see here that this JR vehicle has been in an errored state for the last 16 hours. And then Spidey is currently charging. So this was the mirror robot that we executed here. So finally, we have our alerts system, and I don't think we have any defined here in the demo. And then finally, our role-based security. So we've got the ability to create local accounts associated with an email address. We also have the ability to link to Microsoft Entra ID, and then very recently, I think we've just released an AD or LDAP integration. We've got a full audit trail here of logons and other activities. And then we can assign each of these users to a specific role, and those roles can then have permissions configured here. So we also have, so I think that's it for security. And then finally, and I think this is a good transition point to the next slide, button, we have add-ons. And add-ons are a software expansion that adds new features and capabilities to Lift. They include additional functionality beyond what's available in out-of-the-box with Lift Core. So add-ons are licensed individually and will be maintained, supported, and enhanced by Flexware over the product's lifetime. And with that, I will get the PowerPoint slide back over to Brian, and we'll go back from there. Thank you so much for your time, everyone. You are muted, Brian.
Thanks, Will. Appreciate it. That was a great job. I want to take a few minutes here to talk about our 2026 roadmap. We got a couple of really cool features coming out that Will kind of alluded to. These are add-ons. One of the problems that we see coming up with adding AMRs is when you got multiple vendors kind of occupying the same floor space. Sometimes they trip over each other. And so what we're trying to do, and this is characterized as interoperability. So we're trying to solve that problem. We've got customers asking us to help them with that. And so we're going to come out with a product. We're developing it and should be out in the first half of Q1 or first half of 2026, I should say. It's called Locksmith. And Locksmith is designed to intelligently avoid deadlocks. And a deadlock is when oftentimes two vendors, robots, interact with each other, and their safety mechanism keep them from proceeding. And so what we are doing is our system is learning those paths and through observation, and then it uses predictive algorithms to intelligently avoid those deadlock situations. And this doesn't require explicit route configuration to do that. So that's a huge problem that's occurring right now, and we're solving that problem in the first half of 2026. The other thing customers are asking us for is an ability to view locations and find and visualize locations of multiple vehicles across multiple systems. So one of the powers of Lift is we're bringing in data from all across the organization, and that includes as I mentioned, the fleet management systems. There's really nowhere to get that all in one place, and it makes sense for Lift because we're collecting that data to provide that. And we're going to be doing that with a product called LiveMap, and that is going to provide a 3D visualization of where all your robots, as well as in the future, even people, forklifts, and all sorts of other machines and or vehicles that are related to material movement. So when there is an issue, you can locate that vehicle and deploy personnel to fix it. We're also going to be incorporating heat maps into that, so you can identify areas of concern that you see building up in terms of traffic flow and other things. So LiveMap is something we have early in development, but we're targeting 2026, only in the second half of that as an initial release. All righty, so let's go ahead and wrap things up. I want to talk about next steps, and then we're going to break into QA. So hopefully this was informational for you. I tend to think there's probably three camps of you out there. One was, you're just kind of here just to learn a little bit more about what we do. There may be a couple other folks out there that really have an active project, and they resonate with this, and you need help. And for those folks, I'd say let's schedule a one-on-one call so we can get more detail from you. Others may be anticipating maybe some problems, and you may want to call us in that regard. And there may be a proof of concept project that we can put together that helps you with your next steps on implementing your AMRs. So in all those regards, we'd love to have a chat with you one-on-one. I encourage you to visit the website. It's lift.software for more details. It's packed with information, including videos and more information there. As Ellie mentioned earlier, this recording will be made available to you and also on YouTube. So if you want to share it with other folks within your organization, we encourage you to do that. Before we open up the questions, just to let you know, if you want to contact me and Will directly, feel free to email us. Our emails are provided there. We're happy to answer your questions on a more personal one-on-one note. And so with that, Ellie, I'll turn it over to you. Maybe you can, if there's any questions out there you want to address.
Yes, we do have a few questions, and I'll just say here, I know we're getting close to time, so if we don't have time to answer all of your questions, we'll follow up with you individually and definitely make sure you get answers to all of those questions. But first one here is asking about some use cases. They asked if we could show some, which we won't have time to do that today, unfortunately, but maybe you could share a little bit about some use cases that we have done with Lyft to just share a little bit more about what's available.
Sure. Will, maybe that's something you can handle there. Talk about some of the use cases that you've seen
Sure.
applied.
Yeah, absolutely. So the example that we walked through today is actually we've adapted that from a real life use case that we've run across at many customers, where they need to have an example here would be taking material from a warehouse to a line side staging area, and then you've got a second AMR or second vehicle that's taking data out or taking material from that line side staging into the line and installing it on the line. So that's a fairly common case here. Some other use cases for Lyft is orchestrating manual movements. So basically providing an HMI for manual operators to trigger when locations are occupied, and then that would then call a AMR or AGV to come pick up the material at a location. We can do that automatically as well with photo eyes can trigger location occupancy states. A lot of what we do is actually interfacing, kind of bridging that gap between the ERP system or the WMS system. So if we've got to take a barcode reader that's mounted to a vehicle, do a barcode scan, we'll retrieve that barcode scan, make the call into the WMS with the material, we'll register that material with that says, hey, this material is being picked up by robot X, move that material in the WMS from the pickup location to the vehicle, and then when it gets to the drop, it will drop that material, do an additional scan to validate that that material is the same material that it had on it, just in case. And we're managing all that interaction between the barcode scanner, the vehicle, the robot, and handshaking with the various machines that it has to deal with across the way. One last one, and then we'll get to another question, is handshaking. So where you've got to have an example here is we had a customer where they had conveyors on top of their AMRs. So we would dispatch the AMR to the location. We would make sure that once that vehicle said it was in position, we would then activate the conveyor that was line side to feed the material onto the AMR. And so we would activate both of those. And once the material was confirmed to be loaded, we would then dispatch the AMR to go drop and take it to wherever it needed to go. So, but yeah, those are some example use cases, and feel free to reach out to us for a one-on-one call where we can go into your specific use cases and some of the pain points you're seeing with material movement in your facility. So Ellie, what's our next question?
Yeah, I'll have this be our last one just to be cognizant of time, but I'm going to ask two in one because I think they will be pretty quick answers from you all. And then, like I said, if you have another question or if you have one on here, we'll make sure to follow up with you. So this one is, does Flexware run on cloud or on-prem? And then we also have, do you show or use the AMRs and the AMRs in vehicles of all different vendors. So on-prem or cloud, and then also do we work with different AGV and AMR vendors?
Yeah, so
I'm sorry.
go ahead, Brian.
Go ahead, Will. No, go ahead.
So to answer the first question, Lyft is designed to be run on premises in an air-gapped environment. We found that that's a requirement from a lot of our manufacturing customers that might not have stable internet, where they might not want to rely on external connections to run their processes. And then when you say showing AMR vehicles of all different vendors, I think within our resources view, we will list every vehicle from every integration that we have there with the relevant uptime and downtime statistics, or the states there. So yes, we do every vehicle that we can connect to with our integrations, we can surface that within Lyft.
Yeah, and that's one of the key value propositions of Lyft is to tie those different vendors together so you have visibility and orchestration control over them.
All right. Thanks, guys. I really appreciate it. And thank you all for joining us today. Hope you're walking away with some actionable insights to take back to your team. If you think of any other questions, feel free to reach out to us. You have Brian and Will's emails there, so you can reach out to them. You can also reply to the email that I'm going to send you with the recording, and we can answer any questions, get you set up with a personalized demo, and all of that good stuff. I also just wanted to mention that if you're interested in learning more about the AGV and AMR market, we have a webinar coming up on February 16th that will be with the author of AGV and AMR Robotics 2025. And so that'll be an in-depth interview talking about that report and all of the great insights from that. So if you're interested in that, keep an eye out. We'll send out emails. We'll have it on our website. It'll be on LinkedIn. So as soon as that registration page is live, please feel free to go on and register. But again, thank you and have a great rest of your day.